Welcome to Vital Signs, where we learn how to get healthier from all angles, from the biochemical and nutritional to the things we do that nourish our minds and our souls. I'm Brendon Fallon. Dr. Seheult's current practice is in Beaumont, California, where he is a critical care physician, pulmonologist, and sleep physician at Optum, California. From the forests of Australia, where the eucalyptus trees dominate, to the other end of the world, Finland, where I understand that sauna played a big role in how people dealt with the pandemic, and that this signaling protein, interferon, that basically tells the immune system to get into action, was featured in this process as well. Dr. Seheult, could you lend your insights on how this all worked?
Oh, great question. Where do we start? Okay, so it's interesting that it's in Finland, that it's in a high latitude country where you don't get a lot of sunlight. We could talk a little bit, but we won't get too much into it, about the anthropological or the societal reason why this was used. Maybe it was an adjunct to the lack of sunlight that it developed, and they found that it worked. This is what we know. We know that elevating the body's temperature puts into motion a whole host of defenses in the innate and the adaptive, but particularly in the innate immune system. The central figure in the innate immune system is interferon. Interferon is your friend. It literally interferes with viral infections, and it's very broad. In other words, it's not dependent at all on variants. So if we're talking about COVID, SARS-CoV-2, the fact that we had different variants would not in any way be a problem for interferon, because interferon is able to recognize, in general, things that are self and things that are non-self. And every single one of those variants that we had of SARS-CoV-2 would have been recognized by interferon. Now, interferon is boosted, it is increased when you have a fever. And one of the most interesting things that I found, Brandon, is this. This is a general rule that you can take to the bank every single time. There are multiple viruses that infect the human race, multiple viruses. Almost every single one of them that is pathogenic, that actually gets a foothold, has within its genome some factor which is able to neutralize an immune factor of the human body. The most common one that we see is the neutralization of interferon. We knew that about SARS very early on. That was from 2002. We estimated that SARS-CoV-2 probably had that. We confirmed it with data that showed that the MAC1 gene is actually there specifically to downregulate the body's ability to use interferon. When we do gene deletion of MAC1, SARS-CoV-2 becomes an impotent virus. So there are factors on all of these viruses. I was just studying about Marburg, which is now in the news in terms of what's going on there now in Rwanda and the outbreak there. Guess what? Marburg virus also specifically targets downregulation of the body's ability to use interferon. It's kind of like if you're going to rob a bank. You're not going to be able to rob a bank unless you're able to deal with security and open the safe. And that's what the virus has to deal with. When it's going to attack the human body, it has to have a plan how to get around interferon. And so there are proteins that suppress interferon. There are proteins that downregulate interferon, that prevent the body from speaking to itself or talking to itself. Many of these workarounds that the virus comes up with can be circumvented itself by simply elevating the temperature. And there's a paper that was published in 2022, which I'm going through right now and reviewing. They actually state and come out and say that we've known for a long time that children are able to mount high fevers very easily, but as we get older, we're not able to do that. They are proposing that that in and of itself may be the reason why we saw so much mortality at the older end of the population and not the younger end of the population. So what is this all to say? You're asking me about saunas. I can expand it even more. I would say that anything that can even artificially increase the body temperature is going to shut down viral replication, maybe not 100%, but certainly reduce it significantly. It's going to boost interferon. There's a number of papers that show that when you elevate the temperature, the ambient temperature of the activated lymphocytes, particularly up to 39 degrees Celsius, that you're going to get a tenfold increase boost in the production of interferon. So when you look back historically about what people did before we had medications, specifically to the 1918-1919 pandemic, there were people that were taking people outside into the fresh air and the sunlight, yes, but also particularly there was a group of Adventist sanitariums in the Northeast, which I've studied, And they were using something called hydrotherapy. So this is a way of using water, which has a high amount of heat in it. It takes a lot of heat to raise the temperature of water. But then similarly, when you put warm water or hot water onto someone without burning them, it can transfer a lot of heat and energy to that body to heat it up. And so by using sauna, by using hydrotherapy with wet towels, by using hot tubs, elevating the temperature of the body went a long way in terms of preventing the early pneumonia. So this is early treatment in the 1918, okay? They showed that they had 1/6 of the mortality rate that the Army hospitals did who were using aspirin. So what does aspirin do? Aspirin does exactly the opposite of what you want. It takes away the fever. It breaks the fever. And so there's this dichotomy. What do you do when you see a fever in a patient? Do you try to break it, bring it down, or do you elevate it? And I think that's really at the core of your question about sauna and things of that nature.
One thought comes to mind there when you talk about, I guess it's kind of a knee-jerk reaction that's been developed in the medical thinking to try and to suppress the fever. But isn't there a danger if your body's elevated to a certain temperature for too long that it can be damaging?
Yeah, so when your body temperature goes up, this is why your body temperature is very well regulated. When your temperature goes up, your metabolism goes up, your heart rate goes up, and your seizure threshold goes down. So up to a certain point, it's okay to deal with. Once it gets past 103, I think that's a time to be circumspect and bring that temperature down. But I've never seen anyone have an issue with a temperature of 102, even up to as high as 103. And frankly, as I mentioned, with this paper that I'm reviewing from 2022, there was a lot of benefits, even up to 38 degrees Celsius, which is about 102 or 100 and 100.4 at 38. 39 would be 102.2. Even in that area, which is well below where we would expect to find the negative consequences of a fever, even at those low grade temperatures, there was huge increases in mRNA transcription and translocation to proteins of major portions of the innate immune system. So certainly the body switches over to a very different mode when there is elevated body temperature.
What is the connection between inflammation and a suppression of the immune response?
So there's two types of inflammation in this case. There's the inflammation that might come about from the innate immune system, but the inflammation that really caused a lot of the problems that we saw in COVID, where people were ending up on the ventilators because their lungs were filling up with water, is related to the inflammatory response that we saw with, for instance, IL-6, which is a result of the adaptive immune system. So when the adaptive immune system came on and there was all of these antibodies that were binding the viral particles, that was causing overwhelming inflammation. And that was what was causing the disease of patients ending up on ventilators and not being able to breathe. The way to avoid that is is an ounce of prevention, is to immediately, it's almost like a wildfire, right? So do you bring in, I mean, it's very expensive to bring in super scoopers and planes and helicopters to fight this fire, whereas just a small, like a single engine at the very beginning could have extinguished the fire. It's a similar type of analogy. The innate immune system is the early response with enough water to put the fire out at the beginning, and then you can create the line and mop up later as you need to, versus delaying that or having the fire being able to get around that initial response so that it spreads and now it's become a huge conflagration.